morning, good afternoon, depends on where you are. Welcome to participate in this new webinar. So today let's talk about something newly available in Milesight UG6 series LoLoWAN gateway. First, we will discuss how LoLoWAN gateway works in the LoLoWAN network. And later, you can enjoy the 6 new features like the LoLoWAN basic station, the gateway fleet, Multicast. It always works with Class B in some smart applications. And finally, you can enjoy the noise analyzer and Node-RED directly in the Milesight gateway. Okay, first, I think you must be very familiar with this type of graphic. The LoLoWAN topographic, from the left side to the right side here. First, there are end nodes and devices, no matter the LoLoWAN-based sensors or meters. And the gateway sits in between the end device and the network server as a station here. So the end device sends uplink message with a LoLa modulated frame, and the gateway listens to the LoLa spectrum, and whenever a LoLa frame is detected, gateway will pick up the modulated frame and forward it to the network server over some IP-based network. Like the cellular, 3G, 4G, or wired network, like through the Ethernet cable. And the privacy of the actual payload is ensured between the end device and the whole application server. The encryption and the decryption of the payload. So actually, the gateway does nothing on the packets. The gateway doesn't participate in any encryption works. Gateway is just a dump device here that only relaying or forwarding packets between the end device and network server. So here we can understand the firmware of the software running in the gateway. It mainly focuses on 2 tasks. In the uplink direction, from the end device to the network server, is decoding packets and gateway filtering on the messages and then buffering in case the backhaul connection gets lost. And in the downlink direction, from the network server to the end device, is basically managing the spectral access for the network server. For example, when the network server schedules a downlink, when the network server wants to send a message to the end device, the gateway will check if the slot is still available. If the slot can satisfy all the regional requirements, then the gateway will pick up the slots and put the actual frame on the slot. So the network server has the challenge here as well. The network server needs to handle not only the gateways with different protocols, but also needs to cover different types of uplinks and downlink messages. So the network server is required to be able to handle both complex gateway protocols and applications simultaneously. So now from this top graphic, we can fully understand what's the function of the gateway and network server in a LoLoWAN network. And what's the relationship with our LoLa basic station function? Okay, here, different from the pilot project. That pilot project in the testing is only 1 unit of gateway is usually enough to build up a LoLoWAN network very quickly and easily. And you may have so many pain points when you really deploy or operating gateways in a big quantity at a large scale. For example, if you have hundreds or even thousands of gateways that you want to manage them. Well, in this case, if you operate these big quantities of gateways, the management task should be done from a centralized component. without physical access to the gateway. For example, if you want to change the LoRa network server, if you want to change the credentials or the security keys of end devices, or if you want to change the radio parameters, or if you want to accurate or distribute the channel and the frequency, or if you want to update or upgrade the firmware of gateway, or inspect or diagnose what's going on in your gateways, then you should be able to operate all these works remotely. It would be a big problem for you if you had to physically access the gateway without a centralized component. And on the back-end side, when you run large quantities of gateways, the credentials management is of course very important. You want to authenticate your large fleet of gateways to avoid denial or refuse of service, and time synchronization sometimes may be a pain point as well. But the other question arises when time synchronization or timekeeping, in which level? Well, timekeeping and this synchronization it is. So we actually need it for the gateway, and actually we only need to do the minimum in that regard. And what is LoRa basic station? I think is a really technical issues here. We need to spend a little bit more time to make it clear. As we already talked, in the LoRaWAN networking, gateway listens to the radio spectrum from the end device, decodes the valid packets out of the modulated signals, and gateway forwards the packets to the LoRaWAN, to the LNS, the LoRaWAN network server. And the gateway also transmits the LoRaWAN packets from the LNS down to the sensor. Now, through this function, the functionality of a LoRaWAN gateway, we can better understand why LoRa basic station is designed. It's a software, to be honest, specially designed to address these challenges when you deploy the gateways at scale in big quantity. It's not a simple packet forwarder, because the LoRa basic station can handle the packet flow. It can manage the spectrum access and the LoRaWAN network server backhaul connectivity and many more other functions. So in this diagram, from the left side to the right, we have the antenna and we have the radio front. And over the SPI hardware is driven by some host platforms, such as the Linux-based and the free RTOS-based systems. And more gateways come into play when the base system is actually a tiny real-time operating system with very little resources. So the basic station is software that runs on this operating system, and the communication through the LoRaWAN gateway HAL library, the hardware abstraction layer here. So towards the network server side, we want to finish the task securely, stably, and efficiently, I think, over large gateways. So this station defines two back-end protocols. Here you can find CUPS and LNS protocol. The CUPS, it means Config and Update Service Protocol. Its purpose is to configure the LNS and endpoint and to help to distribute the firmware updates securely. So, you can exchange the credentials, the security keys of the end device, and the relevant information of the firmware updates by the CUPS, by CUPS protocols. So, it's basically just a HTTP code, nothing else, and is invoked either periodically or during the startup by the gateway. And LNS protocol, the LoRaWAN network server protocol, is providing a bidirectional communication channel over the secure WebSockets, a low latency between the uplink and the downlink. So now we can better understand this LoRa basic station software is working as a data pipe between the LoRaWAN network server and gateway. Nowadays, the famous providers like TTN and AWS, they are officially supporting LoRa basic station software. And comparing to the other packet forwarder protocols like UDP and MQTT, the basic station software is highly recommended, the preferred way of connecting gateways to the TTS, the things stack, and to AWS IoT core for LoRa. So customers, you can easily enjoy the plug-and-play experience when setting up a large number of gateways with these famous service providers in a highly secured way as well. And UDP Protocol, UDP forwarder is being the most common among those three of them. Almost all gateway vendors have at least one variant model that supports this Sumtech UDP forwarder. But here are some advantages of LoRaWAN basic station over the legacy UDP packet forwarder, such as the centralized update and configuration management. If you want to change like the firmware of the gateway, if you want to change even the IP settings of the gateway, you can easily manage all of them in that one component, through the LoRa basic station software. And also you can get the static and the dynamic the authentication code through the TLS and the token-based authentication these settings. And centralized channel plan management, it means you can change the channel, you can change the frequencies through this centralized management platform. And of course, we need to time synchronization between the gateway and network server. So it's no dependency on local time keeping. So you can make sure your gateway, the payload from the gateway with the same time, with the right time that as you received in the network server. And gateway fleet is also very useful when we build up a small private LoRaWAN network. If you want to build up a small private LoRaWAN network with Milesight gateways only, the UG6x or UG6, UG6x and UG6x. If you don't want to deploy the network server from the third party, like from TTN, Laureate, or Chopstack, and if you are sensitive to manage those gateways through the cloud-based network server, then you would probably meet some challenges during the configuration. And if unfortunately a gateway was broken, how to deal with the end device? How can you deal with the sensors that attached to this broken gateway? Because the embedded network server can only support one gateway because it's embedded in Milesight gateways. So you have no other option but to add the sensors again to the replace the new gateway. You have to set up the embedded network server again. So I think it's a very boring procedure. And if the project only asks for a few units of gateways to build up a small private network, you may hesitate to try the third party's network server services because it would increase the total cost. Maybe it will charge you a license fee to use their network service, right? So this feature, the gateway fleet, can help you to get away from the above challenges, especially designed for the small private network. There's no technical barriers, there's no technical requirements, just finish all the settings on the web GUI of the gateway. And you can set up one gateway, no matter it's the UG6x indoor version or the UG6x outdoor version, as the master gateway or as the controller gateway. Then you can manage up to 4 slave gateways or agent gateways, up to 4 units, and you can still massive import and connect sensors to the master gateways, and the other slave gateways purely works as a packet forwarder here. So it means in the controller gateway, in the master gateway, the embedded network server will as supporting up to 4 units of Milesight gateways. So you can just configure network server in this controller gateway directly, and disable the network server NS embedded network server settings in this agent gateways, slave gateways. And I think the benefits is obviously you will never worry about the maintenance after deployment, and there's no additional cost. You can directly take use of the embedded network server to manage multiple gateways at the same time, and all the LoRaWAN data from different sources can be aggregated in the controller gateway, and the payload filtering will be achieved securely and efficiently. The end-to-end network security is improved definitely. And be mindful here, it only works to Milesight UG6 series gateway. The UG6x and UG6x, no other brands, no other series, such as neither works in the UG8 series gateway, okay, from Milesight. And I think you may heard about Unicast Broadcast before. Multicast is of course a very popular feature in the communication field. Along with the development of LoRaWAN, we can find the solution scale is expanding, and sometimes we need to deliver a same message or send a command to multiple end devices at the same time. For example, in a smart street light scenario or smart agriculture, where there are a lot of actuators or valve controllers or switches, they might want to receive the same small packet to achieve the automatic turn on or turn off this command simultaneously. Or if we want to carry out the firmware over the air command that send a firmware update or a security update to multiple end devices. So in this situation, if we transmit data separately, it would waste a lot of resources. So the multicast, it comes into play, which allows a number of end devices to hear a single transmission. And these devices hear a transmission will form a group called multicast group. So multicast, it requires the LoRaWAN support Class B or Class C. At least it should support Class B. And Class B, as most popular LP1 technology, LoRaWAN basically has 3 different classes of operation. Now, Class A Class A receives a downlink message only after uplink transmission. So you cannot control the latency, you cannot control the delay. So Class A cannot apply to multicast, is not suitable for multicast. And Class C is another extreme. It always listening, very suitable for multicast, but it takes a lot of energy, so it's not very nice for battery-operated devices, but most IoT devices nowadays are battery-operated. And let's see Class B is actually somewhere in between. It receives a downlink message periodically, so you can control the latency and save the energy. So Class B is super nice to battery-operated device and multicast. And currently, only Milesight UG6 models, the gateways can support Class B. Of course, it supports Class C as well. So you can work our gateways with other Class B supported end devices like meters, controllers, switches, or trackers for smart applications. These applications can send messages to end devices at predefined time slots rather than waiting for the Class A uplink. And when combined with multicast groups, applications can send periodic downlinks to many devices at the same time. And to be honest, Class B development is much more complicated than Class A and Class C. So we are going to support Class B in the Milesight UG6 gateways at first. And of course later, we have planned to develop some other end devices, LoRaWAN sensors, that can support Class B in the near future. And the noise analyzer. Noise analyzer, personally, I think is the most important feature in this upgrading. In this new version, as we all know that the link quality between the end device and the gateway is very important. And there are two indicators to measure the link quality, the received signal strength and the signal to noise ratio. RSSI, it means received signal strength. It gives the indication on the ambient noise level. And here I'd like to share with you a data. Radio link can be considered as good when the RSSI higher than -115 dBm, and at the same time SNR is higher than -7 dB. And when RSSI lower or equals to -120 dBm or SNR lower or equal to -13 dB, the link quality can be considered as bad. If between these two cases, for example, when the received signal strength indicator is good, but SNR is bad, well, the devices, it means the devices are working in a very, very noisy environment. So the SNR must be double-checked on a few more days to make sure that link quality, the radio link, is enough stable to receive the messages. And in another case, if the received signal strength indicator is bad, is lower than -120 dBm, but SNR is good, well, it means the end device is probably too far away from the gateway, or there are too many obstacles between the gateway and end device, too many barriers between them. And since LoRa works at the unlicensed spectrum, everyone can set up a LoRa gateway. Everyone can deploy a LoRa sensors in the field and receives the LoRaWAN traffics. In LoRaWAN protocol, on the frequency bands, the US 915, AU 915, or CN470, where you can pick up, everyone can pick up from those authorized frequencies and set up them in the Milesight gateway and end device to receive and to send packets. But channels, the frequencies, they are really closed. They are really close to each other in the same region or in the same country or surrounding your solutions. Maybe there are other operations, other Aurora solutions is undergoing or in the working. So other customers may probably set up the radio with the same frequencies as yours. So in this situation, your preferred frequencies may probably used by someone else, which would cause the signal interference and increase the packet loss. And in our previous firmware version, in the old firmware version of the gateway, you can get RSSI and SNR statistics as well to analyze the link quality. So here is the picture of our old version. But here you can find it only works for the chosen frequencies, not for the rest of available ones, not for all of them. So we are not sure if those frequencies are the best choice, right? So we need to try several times. We need to wait to see the result. Or sometimes you may probably spend a little bit to spend money to buy another tester on another device to test the ambient noise levels. So both time and money cost are the concerns, right? So the noise analyzer here can help us easily to test the link quality. You just deploy the gateway at a place and enable this function in the web GUI. Then test it for a few days. Then you can get the statistics of the received signal strength indicator, as you can see here in this column chart with different bars and different frequencies here, the channels and frequencies. So with this information, you can get to know those available and more idle frequencies to transmit data and reduce the packet loss. So this function can help you to find out the available one and the relatively idle, not frequently used the channels. So you can reduce the packet loss and make sure the very good link quality between your end device and gateway. And if you have several gateways, well, just deploy them at different places to test optimal, to find out the optimal frequencies in that region with this same function. And please be mindful, this feature only works in the testing period, in the pre-installation stage. So it can assist you to pick up the frequencies. And once you are ready to work the solution officially in the field, please don't forget to disable it. And think of the packet loss. You can enable it again to scan the frequency and to adjust your settings as a debug tool here. It can help you to find out the idle and relatively idle frequencies again. And the last new feature, that is Node-RED. Node-RED is a JavaScript-based tool for wiring together hardware devices, for wiring together APIs and online services. It provides a browser-based, web GUI-based flow editor, so it's very easy to wire together flows by using the wide range nodes in the palette here. here is a little different. I'll be mindful here. The node RAD. The node refers to the components in the node RAD terminology. Are there on this screen, the elements held in the sidebar here on the left. They are not the end devices. They are not the sensors in IoT network, okay? And to some customers, their ideas, their practical experience are much different from the logic that Milesight engineers designed on the web GUI of the gateway. So now with this node RAD, those customers, they can get very flexible configuration with this professional tool with node RAD. And Milesight UG6 series Load 1 gateways are specially for developers and hackers who are looking to test out a Load 1 network. And this UG6 series has built-in node RAD. To start this function, you just simply enable node RAD from the web GUI of the gateway. And you can log in directly with the super administrator password. And this feature is so popular among node RAD junkies experts. So I think one of the many joys of node RAD is very simple method of designing or importing designs in connecting codes by flows. You can set up a node RAD flow that listens to invents and uplink messages, and also you can schedule downlink messages here. So you just drag the nodes from the left sidebar onto the canvas and then connect them by left mouse clicking here on input and output circles at either side, at either end. So click these small gray circles here in the picture. So anyway, you can follow up our user manual to set up the receiving packets on the gateway and transmitting packets from the gateway. More details are available in our user manual. Besides that, you can also enjoy some other features like SMS notification and SMTP notification and manage data by groups and monitoring the status of gateway through node RAD. And in the previous old version of the gateway, for example, if you want to encoder and decode the payload for the applications, you had to operate it manually, Now with node RAD, the process can be automatically achieved. Very convenient. And for the TTN connection, it's very easy to process the device uplink messages and activations with pretty much no code. So if you want to connect with the network server from TTN and the Canny, the application server from my devices, node RAD can help you to short the process and simplify this process. And all the data, to make all the data visible is the main purpose, I think, is another function you can enjoy. So today, at first beginning, we discussed some challenges on the gateways at scale deployment. So the basic station provides basic function to address those pain points with the centralized gateway management facility over the CAPS on TLS protocol and security and time synchronization. Okay. And the gateway fleet function, it allows the network server running in the master gateway, in the controller gateway, and to support up to 4 units of the agent gateways in a small private network. If there are no more than 5 or no more than 4 units of the Milesight gateways, I think this gateway fleet function can fully support you. And Multicast is our new feature. It works with Class B mode ULA, and it can better support some applications that requires less power consumption and less latency, like the street lights in smart cities and the smart switches or smart controllers in the smart watering and smart agriculture applications. With the noise analyzer, you can find out the most optimal frequencies from the signal strength and noise analyzing data to send packets over the relatively idle channels for better communication between end nodes and gateways. And finally is the node RAD. For fans and experts, they can enjoy the data visualization directly on this node RAD. Thanks very much for participating in this webinar. See you next time. Bye-bye.